So I'm down to testing these cells one at a time. I've yanked out of the laptop batteries. And of course, the standard, these are like 25 bucks now. iMax B6 is doing a pretty decent job, just cranking away here. But it's slow going, it's one at a time. So I was hoping to parallelize that, see if I can take a stab at either doing it faster or better, or maybe better logging. Like the best this thing tells me is the number of milliamp hours that it's counted up by drawing half of an amp until it hits 3 volts. And thankfully it's actually a pretty rock solid little workhorse here, because the moment it hits 3 volts it disconnects the internal load and the thing just sits here and waits for me to record that and then write down the actual milliamp hours on the cells and start to bin them. But if you come over here and take a look at what we're working on. So I figured I could probably make my own. I even got the same type of shitty 16:2 LCD screen. It came with one of these goofy Arduino kits that you can get on Amazon, which are pretty cool because they're about the cost of an Arduino, or maybe cheaper. The whole thing's like 20 bucks or so, and it comes with a bunch of 770 displays and LEDs. Not that, of course. Some of these cool distance measuring bits, some other things, some stuff in here I've added since then, but it comes with a remote. Anyways, and a like a generic clone of Arduino. But you get all of this, including the handy little thing, for like 20 bucks, 23 bucks. Totally worth it if you're thinking about buying an Arduino. Grab one of these. All the parts in it are kind of crappy, but they get the job done. They kind of get you started on Arduino stuff, and then you end up buying proper parts from like Adafruit. But back to my battery discharger. My plan was to make this a battery discharger. I can see the awesome soldering iron burn I have. A charger, discharger, then charger again. So that cycle. So charge up a battery, let it sit and become stable. Maybe I'll add some logic there to check for leakage in the battery. But then after some set amount of time, kicking off a discharging cycle, and then recording it for posterity, like the entire discharging curve, because I'll have all that data. I've got voltage and current over time, and that's really all you need to characterize a battery. And then I'd be able to just read the display, pull it off the battery, out of the battery holder, or like one of these 3D printed jobbies from Thingiverse. I'll put the link in for that one. I haven't used it yet, and it was how I burned myself. I'm using this shitty iron that I have lying around the garage, and I'm used to like a proper soldering station where I can put it away, and it would sit in its holster. And I just haven't gotten used to using this one, and I set it aside, and then like an idiot, I forgot that it was plugged in, and I went to go move this entire base and grab the whole thing, and it burned the shit out of me. So, not my first soldering burn, but I was hoping I was done with those. Anyways, the goal here was to sort of quickly prototype it, and then eventually shrink it down to something a lot smaller, or get it down to a trinket. And there's a couple cool things you can do here, and eventually I'll button up actually the short answer is, or in reality, is if I end up being really proud of this thing when I'm finally done, yeah, I'll put out all the 3D printed files and the code I used for the Arduino, or whatever I end up using. I've grabbed one of these little, I think they're called ESP8266. That's what it is. I saw these pop up on Julian Allet's YouTube channel, and it hadn't really dawned on me that in addition to this thing having a little Wi-Fi chipset in it, that's what that bit at the top is the antenna. In addition to having a Wi-Fi chipset, it also is a microcontroller. I mean, it's essentially, it has the same processing power as a little trinket or an Arduino, maybe a little, maybe not as powerful, probably underpowered versus the Arduino in specs. But if you're writing something really simple like I am here, my code before I started using this funky current sensing circuit from Adafruit was just checking the voltage drop across the resistor. Yeah, that resistor looked a lot like one of these guys. It is a 0.01 ohm ceramic resistor, and if you run your load through that, meaning your positive comes in here and then out of there and then off to your load, in my case a light bulb, an incandescent light bulb, when you read the voltage on the left side and the right side, the amount that it drops across that in many or very few millivolts ends up being proportional by a power of 10 to the current that's being drawn. And so I just took two of the analog inputs of the Arduino and read those. Earlier I was trying to use a grid of neopixels, and my hope was with this, similar to, well, you guys don't know about that project. Oh, sorry. So my hope was with this to have the LEDs act as a display. I would diffuse this behind some bit of plastic or paper or something and scroll across some of the same information here. It ends up being pretty human readable when it jets across from left to right. You know, just volts, current, and milliamp hours, and then maybe something to say, you know, test in progress or test complete. Here's your final count for capacity, something like that. Then I get to reduce my BOM or my bill of materials by also having this awesome 64 LED array act as my load instead of an incandescent bulb. So it would say something like, you know, it's 4.2 volts and I'm going to be discharging at half of an amp and the test begins now. And then when it switched over to testing, this thing would go solid white and just irradiate. Like when this thing's at full tilt, this whole back plate here gets really, really warm. And so energy in is energy out. And so if I connected one of these, you know, lithium ion cells to my circuit and powered this guy, I could pull anywhere between 0 and 1 amps. I had to go over amp a little bit, but I was able to tune it to an amp. But what I didn't realize was that there was a bit of I don't know if it's pulse width modulation or what going on, but if I diffused this under light, there ended up being a little bit of a twinkle that you could kind of tell, or you could see some of the, I'd write the same value to all of them to be the same value of white, but some would be a little bit off colored, but then that off color would kind of dance its way through the array. You know, you could like watch a slightly pinker pixel kind of work its way around and do this and then come off to the corner here. It was really peculiar. I haven't gone back to troubleshoot that. I might sometime, but what it meant for my current was that it was dancing all around the place, and it jumped around like 100 millivolts plus or minus, and sometimes it'd be like 30 millivolts, 100 millivolts. And I thought that it had to do with the inconsistency of this A to D conversion that was happening here, but it ended up being the actual load itself that was super accurate and wasn't doing so high. But in the middle of all that troubleshooting, I said, you know, my A to D sucks here. Let me get a made for the job little INA 219 part from Adafruit, which comes on a little package. I could show you the bottom of that, but then I'd interrupt my test that I've got going on here. So this guy actually detects the high side of the voltage and then detects the current because you run the power in and out of here. On the other side, there's also a very similar resistor to this guy. I think it's like a 0.1 ohm resistor, maybe 0.001. I don't know. And it's doing the same math, but it's doing all that for you, and then it's kicking it out over I squared C, and then I squared C back to your Arduino. So when I'm done here, I'm going to try and get my pin count down low enough and get rid of this display, which has a shitload of pins, just to give you a little bit of data. I'm hoping to go I squared C with that as well. But I'm hoping to get my count down so that I can use something like this because it's cheap and like $5 cheap. And I might even be able to find something cheaper than this and really get this whole project down. My end goal is to have you know, something as small as like a tiny little breadboard like this or a little prototype board connected. And if I don't go with the trinket, I'm going to actually have this guy, which is Wi-Fi enabled, running some of the same really basic code to check for voltage and current over time. And then this one's really nifty. This is the ESP8266 that I spoke about earlier. And if I can get all of that working, the code working on this guy, he can report back the state of the test to like a website or over TCP to my local network, and I can do all sorts of fun stuff like that, like tweet myself when the test is done, or send myself a text message and say, hey, this one's done. It was 2,500 milliamps, whatever. I like that. I think that's really cool. And I mean, this thing's tiny. There's something I can give you for scale. Some of you guys know what 18650s are like. So there, that's it next to an 18650. It's just tiny. It's like, it is smaller than a postage stamp in the States. If I had coins, I'd put a coin next to it. But I don't. Nobody carries coins anymore. Super cool little bit of kit. I can't wait to get started with that and pair it with a simpler display, hopefully. Anyways, the goal is to have all of that buttoned up and a decent battery holder to sit there, and then you just, just drop in a battery or two, because there's no reason I can't have a second sensing circuit, except that it eats up some of the GPIOs that are on here. I've got to go take a count, and I think I might have enough where I can do 2 batteries at the same time. And so test each of them, and then the display would tell you what battery A did and what battery B did, and then you'd write on here with your Sharpie and toss it aside, grab another one, and lather, rinse, repeat until you've got them all categorized and they start stacking up in here. So I guess I should give you guys a quick rundown of what's actually going on here. Let me get a pointer. Maybe not a pointer that's conductive. How about, there we go, pencil. Let's see, I guess we can start with the battery under test. Currently I've got a power supply hooked up because I'm debugging this thing. But imagine a battery sitting there. It's got about 4 volts. That 4 volts comes in. It goes through a current sensing circuit here. Later I'll probably just replace that back again with a dumb resistor. That has its own I2C connections back to the Arduino. Then the power goes out of that into the load, out of the load into a MOSFET, and the MOSFET then by a switch coming off of pin 8 over here, that either goes high or low and gives it the signal to connect ground or not connect ground. So that's what this guy is that comes out here. So when this light bulb sees both 4 volts from here and then ground, that completes the circuit, and you get the brightness that is happening over here. It's a little bit too bright, and I just happen to have some old incandescents. I like the incandescents because they give me pretty decent current, or like a steady value, even though they're designed to get warm. So once they get nice and warm, they stabilize really well. Had some of these laying around, and I haven't burned an incandescent bulb for my personal flashlights in many, many years, so I'm glad these are getting some use. So it comes out of there. That ground is connected. There's some other pieces on here, just ignore, like some of these capacitors. I was trying to earlier, instead of using a MOSFET, I was trying to use a little 5-volt controlled relay. That's what they're called, an actual relay. And it worked okay, but again, it's you have to decide, like, do you want the light bulb to be on when this is energized or on when it's de-energized, and then also, if you, I don't know, it's on here. Now it's on this. When you look at the schematic for this, one of the things that it does inside there is there's a little coil across 2 of the pins, and it's becomes electromagnetic, and it yanks the actual switch closed, and that electromagnetism, or the wire wound for that, ends up back feeding into the Arduino and like changing its ground reference. It like almost kind of like drives negative voltage back into a positive voltage line, and this thing gets all confused and says, fuck that, I'm out, and then it just immediately reboots and the test starts over again. And so that was happening at the end of the test when it would close the relay, and then causing me to lose my milliamp hour count, which kind of sucked. The fix for that was really simple. It was a diode. I thought it might have been a capacitance thing. I might have thought it might be drawing too much power, so I had to do that in there. I didn't have an actual regular diode laying around except an LED, and it worked just fine. I just put it in there backwards, if you will. So I put the cathode on the positive side, which is not intuitive. So it wouldn't light up, except when that relay collapsed and it was trying to throw voltage back down the line, this thing would blink and ended up keeping this thing up and running. So there's a little bit of a troubleshooting tip. If you're trying to use relays, you've got to have a diode in there. That comes in. Arduino checks to see, what current is being. I've got some simple code to say, like, is the voltage dipped down to 3 volts yet or not? If not, keep on trucking. And then it does some simple math to take the current at that slice of time and then add it to a running total of current over time, so milliamp hours. And so this can actually fluctuate, quite a bit. And each time, like if I disconnected, I've got 2 light bulbs over here, and if I disconnected one of them, this would drop down to half of that, and then this would stop counting up half as quickly actually. So what I like about this is even if my resistance changes, or because V over IR, as the voltage changes, you can't, in your code, if you're doing math to try and determine what the milliamp hours are, you can't hard code 4 volts because it's not going to be 4 volts through the entire curve of the discharge. And you also can't hard code your load. I could have just come in here and said, oh yeah, sure, every time I boot this thing up, I'll be giving you 500 milliamps. But if you look here, it's not exactly 500, it's 492. If you've been watching this video, it's probably fluctuated some. There's 493.1. Like, those little bits matter, and if you're trying to be accurate, then you should account for them. And I also wanted the ability to maybe switch on more and more like physical loads, like maybe adding different MOSFETs and allowing a user to select between maybe 2 loads, like 500 milliamps and a whole amp hour. It's giving you some flexibility, and you want to write your code so that if that changes, or somebody is going through this list of stuff that I've got and decides to go with a different resistor or a different light bulb for that matter, then they're not completely screwed or getting weird numbers. So there's that. And then the Arduino does that math for you and tells you, yes, that's what the current stuff, and all that's being kicked out over serial so that I can log it. But I thought since I'm out here in the garage doing stuff, I wanted to have a quick visual of what was going on. And so this came as one of the displays in that cheap little $25 get you started Arduino kit, and it uses all these other funky lines because they also sell this thing with a SPI or an I2C interface, but this is like the cheapest thing that they could get in here. So they got rid of one extra chipset to do that conversion. They're asking to wire up these 5 plus ground and power. Anyways, that's a bit of a kludge there, but it works, and it gives you a readout here, which is kind of nice. And then lastly, there's a knob here for the purposes of contrast or brightness. I'm not sure what we're fucking with there. I think contrast, because brightness is just like a solid LED that's just irradiating through here. And that's it. So an update on characterizing all these funky batteries to try and make a cool little battery pack for the electric bike. I'm hoping to get them done as soon as possible, and maybe come up with, I think I'm slightly addicted to just going through and finding them. I feel like there's got to be some term for this where you take something that was destined for the landfill and repurpose it, or like maybe there's some sort of medical condition for applying feelings to inanimate objects, like personalizing them a little bit, like not that I know these batteries personally, or like I've used them my entire life, but it breaks my heart to think that they were going to just go to a landfill when they actually had a perfectly good, they've got capacity left in them. They can be put to some use. And so when you can pick these things up for just pennies, right, by buying quote unquote dead laptop batteries, and then finding out that there's only one cell that's killed the entire pack, and then you rescue the other ones and put them to good use. I don't know. Something tickles me about that, and so I think that once I'm done with this battery pack and I've got it in the bike as like I'm planning on using it as like a backup or a range extension for the bike, because I'm actually going to go lithium phosphate on that. But I'm starting to get addicted to just the idea of building battery packs out of these things, because they're just so energy dense. I just love them. I have the feeling that I'm going to probably want to buy a lot more of these and just keep making battery packs of different shapes and sizes and different purposes. And so building a proper tester is, step one in that whole process. And then a number of goofy standalone chargers. So I don't know, come back to the channel if you guys want to keep watching more and more of these battery experiments. Until next time, subscribe, I don't know, comment if you know what the term is for applying emotions to inanimate objects. Put that in the comments. We'd love to have you share it with the rest of us. Thanks for watching.